DNA in human cells and how it controls the growth and development of cells. Then maybe we can explain a very important observation that when we try to grow most human cells in the laboratory, the gene is programmed to divide only a certain number of times before they die. Now, this differs with the type of cells. Some cells, like nerve cells, only divide 7 to 9 times in the total life. Others, like skin cells, will divide many more times. But finally, the cells stop renewing themselves and they die. And in the cells of the human body itself, in the cells of every organ, or every type of tissues in the body, the same thing will happen eventually. Okay, you know that all of a person's genetic information is contained on very long pieces of DNA called chromosomes. 46 of them are in the human cell, and that 23 pairs of these chromosomes are very large and sizes. Now, if you look at this rough drawing around them, one chromosome is about to divide into two. You see that it sort of looks like, well, actually, it's much more complex than this, but it reminds us a couple of springs linked together to coil up pieces of DNA. And if you stretch them out, you'll find they contain certain genes or certain sequence of DNA that help to determine how the cells within the body will develop. And researchers work really carefully at the DNA in chromosomes, though. They were amazed we all were to find that the only fraction of it, maybe 20 to 30%, converts into meaningful genetic information. It's incredible, at least it was to me, but if you took away all the DNA that codes from genes, you still have maybe 70% of DNA left over. That's the so-called junk DNA, though the word junk is used sort of tongue-in-cheek. The assumption is that even the DNA doesn't make up any of the genes, it must serve some other purpose. Anyway, if we examine the ends of this coil of DNA, we will find a sequence of DNA at each end of every human chromosome called a telomere. Now, a telomere is a highly repetitious and genetically meaningless sequence of DNA, what we are calling junk DNA, but it doesn't have any important purpose. It's sort of like the plastic tip on each end of a shoelace. It means not reveal the little process that keeps the rest of the shoelace, the shoestring, from unraveling into weak and useless thread. Well, the telomeres at the end of chromosome seem to do about the same thing, protect the genes, genetically functional parts of the chromosome from being damaged. Every time one cell divides into two pieces of ends of chromosome, the telomere get broken off. So after each division, the telomere gets shorter, and one of the things that may happen after a while is that pieces of the genes themselves get broken off the chromosomes. So the chromosome is now losing important genetic information and is no longer functional. But as long as the telomeres are at certain lengths, they keep this from happening. So it seems that by looking at the length of telomeres on specific chromosomes, we can actually predict pretty much how long certain cells can successfully go on dividing. As some cells just seem to keep on dividing regardless, which may not be always a good thing if it gets out of control. When we analyze these cells chemically, we find something very interesting. There are chemicals in them. An enzyme called telomerase. As which of the telomere break off from the end of a chromosome, this chemical, this telomerase, can rebuild it, can help reassemble the protected gene that the chromosome is lost. Someday we may be able to take any cell and keep it alive, functioning, reproducing itself essentially forever through the use of telomerase. And in the future, we may have virtually immortal nerve cell and Immortal skin cells were rare because of this chemical. Telomerase can keep the telomeres on the ends of chromosomes from getting any shorter.